Hello everyone, this is Priya Nandwani from ITM University Gwalior pursuing Electronics and Communication Engineering. Today I am going to present my microwave oven presentation and before starting the presentation I would like to thank Emertxe Information Technologies and all the teachers, those who have supported us throughout this journey and make us understand and provided us with good knowledge and tools so that we can implement this project. So, moving forward, we have learned many things in this internship, and in this particular presentation, I have covered C programming, microprocessor and microcontroller, embedded systems, architecture of embedded systems, types of embedded systems, embedded C, microwave oven, tools required for the project implementation. Then we will see about the state and level detection, matrix keypad, and interrupts and timers, CLCD, and at the last we will see about the project demo. So let's move forward to the C. So in C we have learned about variables and constants, how to declare the variables, what are constants. We have learned about different data types like float, integer, double, long, and we have also learned about taking how to take input and output from the like how to take input from the user and display it as a output. We have learned about different operators like arithmetic operator, relational operator, logical operator, bitwise operator, assignment operator, and other operators. And we have also seen control statements like if else statement, if else if statements, nested if else. We have also seen loops, which includes for loop, while loop, do while loop. And we have also seen switch statement, continue and break statements, and go to statements. Further, we have also covered functions, strings, pointers, storage classes which include auto, register, static, local, static, global, extern in this particular presentation, in this particular internship. And we have also learned about the memory segments, different memory segments, and about the preprocessor. So after the C programming, we have learned about the microprocessor. So microprocessor is basically a digital device on a chip that can fetch instructions from memory, decode and execute them, and give results. So we can see it covers basically three basic tasks, which is first one is that it performs some basic calculation using ALU. Then second one is that it helps in moving data from one location to another, and it has a program counter, which is a pointer that stores the address of the next instruction. So here we can see that the microprocessor contains the ALU, control unit, and the registers, and ALU is performing the operations, control unit is controlling all the operations that are happening, registers are storing the data. So we can see that microprocessor is just like a processing unit or brain of the system. So it performs all the operations, but for it to perform any operation, it needs an input device and it also needs an output device. It also needs a memory unit. They are externally attached to the microprocessor, but microprocessor as a whole does not contain input device, output devices, or memory unit, or even other peripherals. So that's why we need to use a system like microcontroller, in which not just microprocessor is there but different peripherals are there which are on board. So we can see here a microcontroller is a small computer on a single integrated circuit that is designed to control a specific task within electronic systems. So it controls a specific task. It combines the functions of central processing unit, memory, input output interfaces all on a single chip. So here we can see that different parts are there: CPU, then memory, RAM and ROM, input output ports, interrupts, serial communication, ADC, DAC, analog to digital converter, digital to analog converter, bus, timers, counters. These are all part of the microcontroller and they are integrated on a single chip. Some of the common microcontrollers are Altera, analog devices, ARM, Atmel, etc. So moving forward, let's discuss about the embedded systems. So what is an embedded system? So embedded system is a computer system, a combination of computer processor, computer memory, computer input-output peripherals that has a dedicated function. So embedded systems are used for a dedicated functionality. For example, industrial robots are used for a specific task. Digital cameras are used for a specific task. It could be taking a picture, recording a video, but it cannot perform many things. It cannot perform the processing on it. So embedded system is very uh, it performs a very dedicated function. It is not general purpose. And in simple language, we can also say that embedded system is a combination of computer hardware and software designed for a specific function. Now moving on, uh, architecture of embedded system. So as we have discussed earlier that embedded system include software as well as the hardware part. So software part is the part in which we insert the code that we write, and the hardware part are the different peripherals that are connected together to perform a particular task. For example, if I am developing a system which is measuring the temperature in the environment using the Arduino. So firstly we need to interface the sensor to the Arduino board. So that contains the hardware part in which we are doing the interfacing. It could be we are connecting VCC to the 5 volt ground to the ground pin, and then at one pin we are connecting it to the digital pin. So this is simply interfacing, but it will not work just by interfacing. We need to insert some code inside it for it to work. And for inserting that code, we write the code in the integrated development environment, and that we insert that code into the microcontroller board, and then it gives an output. So it's similar to this, and we can see that there are many onboard peripherals like RAM, sensors, other blocks, which may include LCD, which may include buzzer, LEDs, clock source, power block, communication interfaces, RAM, flash storage, clock source, sensors. So these are all combined together and they are on the onboard. Like uh, they all comprise together to form an embedded systems like sensors. uh, Sensors are like input, clock is an input device, power is an input device for the processor, but through some different blocks it is giving the output. So we can say embedded system contains many different blocks. Moving forward, there are majorly on the basis of two types we divide the embedded systems. So based on the performance and functional requirements, real-time, networked, mobile, standalone are the four categories of the embedded system. So real-time is an embedded system which has a hard real-time constraint, like any application which we use in military, or we which we use for a national level safety, uh, for uh, for applications in car related to, like we can say, take the example of accident alert system. So this is a real time example of embedded system, because if the if a particular task is not performed within the time limit, so it can also compromise a human life. And networked embedded system is an embedded system which depends on the external network, be it Wi-Fi, Bluetooth, or any other network, uh, based on that it operates. And mobile embedded system is any embedded system which is movable, which can move from one place to another. It includes drones, it also includes a car. Car is also an embedded system, and it is a mobile embedded system. Standalone embedded system is an embedded system which doesn't require any uh, external sources or external inputs for it to operate. It can operate on its own. Is an uh, is a standalone embedded system. And based on the performance of the microcontroller, we divide it into three categories, which is a small scale, medium scale, and sophisticated. So, small scale embedded system includes any microcontroller which is 8-bit or 16-bit, and it has very limited resources in terms of memory, processing, and all. And in medium scale, we generally use 16-bit microcontroller to 32-bit microcontroller, and it is better than the small scale, and it has more resources compared to the small scale. And sophisticated embedded system uses 32-bit or 64-bit or even more bit microprocessors for it to operate, and it has a hardware wide hardware with different functionalities and wide software. And it can be used for major purposes because its resources capability is very high compared to the other two embedded systems. Now talking about the embedded C. So embedded C is a popular programming language in the software field for developing electronic gadgets. Each processor used in an electronic system is associated with embedded software. And embedded C is used for programming all the electronic devices, all the embedded systems generally. There can be many languages, but it is the most popular language, like mobile phones, washing machines, digital cameras. So, in an embedded system programming, C code is preferred over other languages due to the following reasons: because it is easy to understand, high reliability, portability, and scalability. And also, one more point is there that C language is closest to the hardware. So, we generally prefer C language, C or C++ language for writing a code for an embedded system. So, moving forward, talking about our project microwave oven. So, microwave oven or simply microwave is an electric oven. We know that we generally use this for heating and cooking purposes in our home, and it uses electromagnetic radiation in the microwave frequency range. So, nowadays there are many more functionalities in the microwave oven, but in this application, in this project, we are going to implement four important mode of the microwave oven, which includes the microwave mode. So in this we can set the time for which we want it to microwave, and then it can start the timer, and as the timer will reach to a particular value, the timer will be up. And same is the grill mode, but grill mode uses the electric or gas element to produce direct heat, often used for grilling meats and melting cheese. So it uses electric or gas element to produce direct heat. And there's convection mode. So this is a quick way of cooking food. So in this, firstly we give the temperature to the microwave oven, and then at that temperature it is preheated for 3 minutes, and then we can set the timer for cooking. So it is a very quick way of cooking the food because already the oven is preheated. And in the start mode, we can say that it is a quick way of heating something. So we just put it inside the microwave oven and just press the start button. So it will heat the food for 30 seconds, but we can also increase the duration by 30 seconds if we press the start button again. So these are the functionalities we are going to implement on the microwave oven. So these are the project requirements. So we are going to implement something like this, that as we open the microwave oven, so something like this on the LCD should pop out, powering on microwave oven. Then after that we should be given with the four choices: micro, grill, convection and start. And as I choose the first option, then something like this should pop in the screen: power 900 watt. And after that I can set the time. And as I set the time, I can click on the hash button for it to start. And if I want to change it, then I can press the clear button. Then as it will reach, the time will be up. So something like this should be displayed on the uh, something like this should be displayed on the LCD, and the buzzer should also ring. And in the convection mode, so grill mode is same as the micro mode. So let's talk about the grill convection mode. So we are given three values for to enter the temperature, and after entering the temperature it is preheated for 180 seconds, which is 3 minutes. And after 3 minutes we can set the time in this screen. Something like this should pop out and we should set the time, and then it can start the cooking. And there should be options like this available for we to start, resume, pause or stop it based on the numbers we press. And in the start mode, as you can see, it we can heat it for the 30 seconds. And if I want to increase it by 1 minute, I can press the start button two times for it to increase by 1 minute. And if I want to pause it, then we can press the 5 button. And if you want to stop it, then we can press the 6 button. So let's move forward. So what tools are we going to use in this uh, project? Are X8 compiler and MPLab XID, PIC16F877A and PicSimlab. So Xe8 compiler is the cross compiler we are using for converting all the programming code that we write to the machine code, and it is specifically used for the PIC family, PIC microcontroller boards. And MPLab XID is the integrated development environment in which we'll write the code. We'll debug it and configure microcontrollers and digital signal controllers. So it is basically used to develop for embedded system development. And PIC16F877A is the microcontroller board, 8-bit microcontroller board that we are using in this project. And it is a very famous microcontroller board, and it is commonly used in embedded system. And PicSimlab is a software simulation tool. Since we don't have the hardware with us, so we can see the same simulation in a software without using the actual board. So this is all about the tools required. So moving forward, let's talk about the level detection. So level triggered switch is implemented by the pull up resistor. So this is a pull up resistor and this is a pull down resistor. If we change the position of the resistor and the switch, then we get the pull down resistor. So in a level triggered switch, what happens as it reaches to the up level or the down level, so a particular action is triggered. So if I talk about an application, something like a level triggered LED toggling, a level triggered switch through which an LED should be toggled. So as it will reach to the positive or negative level, the LEDs should start toggling. So in the project implementation during our internship, we learned how to toggle the LED using negative level triggering of the switch. So as the negative level would reach, then the LED would start toggling, and as I would release the switch, so the last state would persist until I press it again, so it will start toggling again. So this is the level detection. So now let's talk about the state detection. So state detection is State triggered switch refers to a switch or device that changes its state based on the current condition or state it detects. Rather than reacting to a specific event or input, it switches when it senses that the system or environment has changed a particular state or condition. So if I move from high to low or low to high, like in this case, low to high or from high to low, then that particular action will be triggered. For example, if I press a button and the LED blows up, and if I release the button, the LED still blows up only. Uh, it doesn't get off. And if I press the switch again, then it gets off. And if I release it, then it remains off. So something like that is can be said as a state detection, because we are changing the states, and as we are changing the states, the particular action is taken. Then talking about the matrix keypad, as we can see, matrix keypad is used for taking the inputs from the user. As we can see, matrix keypad is seen in microwave oven, gas pumps, and calculators. It can be connected to a breadboard, which is also used for prototypes and inventions where things like codes, times, and other values have to be entered. So in our case, we need to enter the temperature. That's why we are using the matrix keypad. And in this, pull-up resistors are used, three pull-up resistors, and then we are also using these pins which are connected to the uh, output, which are connected uh, as an output, and uh, these are connected as an input. These pins are connected as an input, and these are connected as an output to implement the matrix keypad. Moving forward, we have learned about the interrupts. So interrupts are the events that temporarily suspend the main program and pass the control to the external sources and execute their task. It passes the control to the main program where it had left off. And there are two types of interrupts: hardware interrupt and software interrupt. So as an interrupt is generated, then the ISR function is executed. As we can see, ISR, interrupt service routine, is a specialized subroutine or function in a computer program or microcontroller firmware that is designed to handle and respond to interrupts. So when an interrupt occurs, the processor or microcontroller temporarily pauses its current execution to execute the ISR associated with that interrupt source. And IVT is an interrupt vector table which maps the interrupt sources to their respective interrupt service routines. When an interrupt occurs, the system uses the IVT to find the appropriate ISR to be handled. So it just maintains all the ISRs that need to be executed and find the appropriate ISR that needs to be performed for a particular interrupt. So it manages all the ISRs. So moving forward, let's talk about the timers. So timers are a very important part of an embedded system. Without timers, we cannot control, we cannot time, we cannot schedule the events. So it is a very necessary part of the embedded system. And as we are counting the time, so we need timers. So timers is nothing but a binary counter that can be configured to count clock pulses. And once it reaches its maximum value, then the overflow flag will be set, generating the interrupt if enabled. So this is the flow diagram, which can be easily seen, through which we get even more clarity that this is the external clock, this is the oscillator, this is the clock select, and through which a signal is generated, clock is generated, and then we use a pre-scaler. And after using a pre-scaler, we are uh, counting it, uh, counting the time until it reaches its maximum value. And as it reaches its maximum value, the overflow flag got set. And as the overflow flag is set to 1 and interrupt is enabled, then the if interrupt is enabled, then the ISR function is executed or the interrupt is generated. And in PIC16F877A, there are three timers: timer 0, timer 1, and timer 2. So timer 0 is 8-bit and timer 2 is also 8-bit, but timer 1 is a 16-bit timer. And in this project, we have used timer 0 and timer 2. So moving forward, this is the CLCD in which we display the information. We can see use an embedded system to provide visual feedback and information to the users. And CLCDs are widely used in embedded systems for displaying text and basic information due to their low power consumption, cost effectiveness, and easy of integration with microcontrollers. And here we can see the pin configuration, which includes ground, 5 voltage, contrast, in through which we can also control the contrast of the CLCD screen using potentiometer. There's a pin called register select, read and write pin, enable pin, 7 digital pins, 7 data pins, and LED positive and negative, which is used to control the backlight of the liquid crystal display. And why we are calling it CLCD is because we can display all the characters uh, in this LCD. We can display any character in the LCD. So now let's see the project demo. Before seeing the project demo, let's see the MPLab XID. In this MPLab XID, here I have written the code. So this is my project, and these are all the files that I have written. Uh, so these are all the header files. As we can see here, these are all the header files in which we have done prototyping, some declarations, so that the overall program becomes human readable, as we cannot remember all the registers. So we call it with a human readable name so that it becomes very easy for us. Some function prototyping is also done. Here we have done some prototyping, and we can see these are all the code. This is main1.h, main1.c. So this is a C file. We can see this is the file that has been implemented, and there are many more C source files which we can use in this by calling the function. So now let's see the simulation. So when we write a particular file, when we write all the source files and header files and we build it, we basically convert it into a machine level code which is generating the hex file of the code. So I have already uploaded the hex file of this particular project in the PicSimlab. So I am reloading it here again. And in this PicGenius board, you can see this is PIC16F877A. Before uploading, uh, let's see about the microcontroller board. So this is PicGenius PIC16F877A. Clock is 20 megahertz, and this is the microcontroller board, and with 16 to 4 display because it contains 16 columns and 4 rows. So this is a 16 by 4 liquid crystal display, and these are also the displays. This is the matrix keypad. These are the LEDs. These are resistors, and this is the microprocessor. And we can see there is a fan also, and here is a buzzer. Here is a temperature sensor, and many different this is a reset button for it to start executing from the very start, and this is the memory. So these are the different ports. These are the in circuit serial programming if you want to program the microcontroller board. So these are some of the peripherals of the PIC16F877A. So let's see the simulation now. So I'm reloading the last file that I have uploaded in this. So as we have seen in that project requirement, firstly we are seeing powering on microwave oven. Now I am choosing the first microwave mode. So the power is displayed. Now I'm setting the temperature. So let's set it for 3 seconds. But if we want, we can set 1 minute also, even 20 minutes also. But since we are seeing here, so I just want to implement a small duration of time. But if I click 1, so it can be implemented like this. But since I want to clear it, so I'll just press the star button, and I'm entering only for 3 seconds. So let's enter the hash button for it to start, and see, times is up. Uh, Now let's choose the grill option, second option, and I'm setting the time as 5 seconds, and I am pressing the hash button. So if I want to stop it, then I can press the button 6, and instantly it will come back to the front screen. So let's implement it again and press something else. So I'm implementing it for the 4 seconds, and I'm pressing the hash button. So if I want to pause it, I'll press the 5 button, and uh, it stops. And if I press the 4 button, it resumes again, and the times is up. So now let's choose the convection mode. So as I choose the convection mode, uh, I can put the temperature. So I am putting the temperature uh, 45 degrees Celsius. So as I enter the 45 degrees Celsius, I can press enter if I'm clear with the temperature, and if I want to change it, then I can press the uh, star button. So I'm pressing here the hash button, and it will start the preheating. We can see the time is going down, but since we can't wait for 3 minutes, so let's reset it. So reset will make the program start from the very start. So we can see it is starting from the very start. Now let's see the fourth option, which is the start button. But in convection mode, after 3 minutes, we can set the time same as the micro and grill mode, and the timer will count up to the maximum value, the timer which we are setting, and after that the time will be up, and the screen will again come back to this main screen in which we can choose the option. Then let's see the fourth option, which is the start button. So as I press the start button, I can see that the timer itself has started for the 30 seconds. And if I want to increase it by 30 seconds more, then I can press the 4 button. So it will increase by 30 seconds. If I want to increase it by 1 minute, I can press it 2 times for it to increase by 1 minute. Then I can also pause using the 5 button, and I can resume it again using the 4 button, you can see, and I can stop heating by pressing the 6 button, and it comes back to the main screen again. So this is my project implementation, project demo. uh, so at the last, I want to say thank you, Emertxe Information Technologies, and all the teachers for providing this incredible opportunities to not just me but students like me who want to make their career in the uh, core field like embedded. So I want to thank them all. Thank you.